Okay, so the first portion of this is for 18.1. Do you remember how to convert from degrees to radians? Okay, good. So first of all, we have 210 degrees. So we know that is a degree, by the way, because it like literally has the degree symbol. If you don't see the degree symbol, then it would be a radian measure. Okay, which will happen. Okay, so to find a radian measure, you simply multiply by pi over 180. Okay, so the way that I'm thinking about this is I'm going to kind of squish this as one fraction and go 210. I'm going to kind of ignore the pi here for a second, and I'm just going to reduce 210 over 180. So I notice the zeros cancel. And then 21 and 18 are reduced by 3. So 7 pi or 6. Okay. Okay, now arc length. Do you guys remember how to find arc length? Okay, if you don't remember, write this down. So arc length, so that's like the distance around a circle. Hold on. Okay, for some reason they decide that S is going to be the variable that represents arc length. In last period we decided it was S because S is like got the most arcage going on. No, because S like curves and then has another curve.
So is W.
You're just supposed to agree. Don't overthink it. Anyways, all you do is you take the radius and you multiply by the angle. Okay, so R is representing the radius of the circle. Radius. And the angle has to be specifically in a specific form. It must be in a radian measure. And that's the part that people forget. Okay, you have to use the radian measure to find arc length. So, if we're going to find the arc length for question number 1, what do we do? Okay, so what's the radius for this scenario? Do you see it up here? So the radius is 5, so our S will be 5 times what? 7 pi over 6, the radian angle. And you all have fancy calculators sitting there on your desk. Let's see if you can use it. Make sure you know how to type this in correctly, that way you don't screw it up on the test. What? Oh.
18.32.
Okay, well, let's round to the nearest tenth. So you said 18 point what? 3. 18.3. Is everybody able to get 18.3? Everybody okay there? And do make sure that you label your arc length because it is a unit of measurement. Okay, so in our scenario we're working with meters, so make sure you label yours. Do I need to do another example of converting degrees to radians? Do I need to do another example of arc length? Okay, I'm going to do a switch relation over here, so I'm just going to go, let's go the other way. How do you go from radians to degrees?
180 over 5.
Okay, so take our radian measure, and this time we're going to multiply by 180 over pi. I always remember this because it's going to cancel the pi's.
Right.
Okay, so the pi's will cancel, so how do you type this into the calculator?
It's 165.
How'd you get that? How'd you type it in?
Oh, I divided 180 by 12 and multiplied across.
And then multiplied by 11?
Yeah.
Okay. Fair game. Or you could do 11 divided by 12 times 180. Or you could do 11 times 180 divided by 12.
Look, okay.
As long as you get 165 at the end of the day, we should be okay. Okay, and make sure that when you're labeling a degree, you use that little degree symbol, so I know that you're writing down a degree, even though it does say degrees. Yes, Jade.
So when we're finding degrees, our calculator has to be in the degree
Mode? Nope. The only time you ever have to worry about whether your calculator is in radians or degrees is if you're using a trig function. So like if you're doing the sine of 165.
have it in the radian.
Today it will not matter what mode your calculator is.
Then so down I don't know how to say
Go
this.
like that.
So 180 and 12, I simplify those.
Divide them. 180 divided by 12.
Yeah.
And then times 11. Yes. Okay, should we find the arc length of this? Just for good measure? Get it? Good measure. Okay, so what's my arc length? S is equal to 8. Good. You see up there that the radius is 8. Times. Good. Times 11 pi over 12. So make sure to use the radian measure. I'll let you calculate that out. And it is okay to give me a arc length as a decimal, even though I don't think this one creates a decimal. I mean, yes, it does. What'd you say? Oh yeah, they're always going to be decimals because it's pies. And let's see, we're working in meters, so we better label it meters. Awesome. Easy peasy so far, yes? All right. Let's do something more fun. Yeah, like a roller coaster.
Oh.
Or maybe this isn't really a roller coaster. It's like what is that one that just goes in a circle? Isn't there one that's like a hammery thingy and it starts out like this and then it goes eventually up?
Yeah.
Anyways, okay, so we're at the amusement park and the ride takes you in a circle, which sounds super fun. Okay, so we're going to start this out knowing that we have a radius of 18, no, that's not an 18, 8.2 meters. The sucker's going to take 6 revolutions in a ride, and every one full revolution takes 16 seconds. Okay, so let's talk about this for a second. Okay, the first thing that I want to figure out is how far is one full revolution. Okay, so if I'm asking you for one revolution, how would you figure this out? Okay, good idea. Okay, so say that louder so everybody can hear you. You said
360 degrees or at
16.4 meters. Oh, I see you doubled your radius. Oh, okay. You're on the right idea. You're working with the right two numbers. Okay, let me ask you this. If I'm asking you for the distance all the way around, what is one full revolution? What am I asking you to find? I'm trying, yeah, we're talking about circumference or arc length. I'm asking you to find the arc length. Okay, what is the angle of one full revolution? In radians. 2 pi. So all I'm going to do is I'm just going to do the radius times the radian angle, okay, to find one full revolution. So the radius in our case is 8.2. 2 pi is our angle. So somebody's got a calculator that can tell me the complete distance of one full revolution.
Oh, it was clear. Cool. One up.
Okay, why is this taking so long?
Well, we was done with that and it was clear. I think I just stopped.
Come on, come on. Somebody's got to do
There
it.
we go, 51.5.
51.5. Thank you, Sean. Okay, and we're talking about meters, right?
What?
Okay, so that right there gives me some information about A. Can you answer A for me? A rider travels about 422 meters during each revolution. Do you agree with that?
No.
I would definitely not agree with that. They must be thinking like in 6 revolutions, right? That's way too far. So I'm going with big fat false, not each. Okay.
No, not these things.
B. What? Okay. Okay, so B says a rider travels an angle of 125 degrees in about 5.6 seconds. Okay, so what are we talking about? How fast somebody travels. Speed. We're talking about speed. Does anybody know a formula that relates how fast something is moving with a distance? Yes, I knew it would come back to you. So we're going to talk about distance is equal to rate times time here. Okay? So the first thing that I'm going to do is I'm going to figure out how fast they're moving in one full revolution. Okay? Because that's the only thing I really know at this point in time. Okay? So looking back here, okay, so it says on the paragraph, one full revolution takes place every 16 seconds. Okay, so 51.5 is equal to, we don't know what the R is, and that's going to be multiplied by 16. So you're one step ahead of me now. Whoops, it's coming. There we go. We divide by 16. Very good. So can somebody please tell me what 51.5 divided by 16 is? And we will figure out how fast we are moving.
3.22.
3.22, and we're talking meters per second. Wow, that's fast. Maybe. I don't know. At angular speed, we're talking torque. Anyway, sorry. Okay, so now let's talk about B. So it says this time they're only going to travel at an angle of 125. So how are you going to figure out how far 125 degrees is? What's that? Okay, so we're going to find the arc length of 125 degrees, right? So I know that arc length is found by doing the radius times the radian measure, but 125 is not a radian measure, so how can I figure out what 125 is equal to in radians? Pi times 180. So, so what's 125 over 180 reduced? Divide by zeros.
No, it's zero.
So you gotta divide by 5, yeah. So it's like 25, 36. Is that right? So my radius is 8.2. I'm going to take that and multiply by 25 pi over 36. Can somebody find the distance of a 120 degree angle? Why did I? Because I need to figure out, so it says a rider travels at an angle of 125. So the first thing I have to figure out is how far that is. So I'm finding the arc length of 125 degrees. 125 over 180 reduces to 25/36. That's just a reduced fraction. It is true. 17? 17.89. I like that. Okay. So now, if we know how fast we're traveling, we know the distance. How do we figure out how long? Okay. So we're using distance equals rate times time again, right? Okay. So this time our distance is only going to be 17.89. We know our rate is 3.22, and we're trying to find the time. So, to solve that, we would divide by 3.22. So what is 17.89 divided by 3.22? Good, 5.6. So I'm going to call that one true. That one is a true statement.
5, 6.
Agreed. 5.6. All right, we're not going to talk about angular velocity right now. Were you excited about angular velocity? Do you know the equation? No? It's like starting to get into physics. So if you like this stuff, you should take physics. It's good stuff. I really enjoy physics also. Okay, now D says a writer travels 38.6 meters when traveling at 270 degrees. So how would you do D? How would you make this decision? Okay, so a writer travels, we're talking about a distance. Okay, so distance in terms of a circle, we're talking about arc length. Okay, so to find this one, I'm just going to do the radius times the radian angle. You just took a unit circle test. I hope you know what 270 degrees is in radians. Very good. 3 pi over 2. And what is 8.2 times 3 pi over 2?
A number.
Is it 38.6?
Maybe. We'll find out.
It is? It is true.
We're not doing the velocity.
Nope, not on that one. That one has nothing to do with time.
Can I take a picture of that and use that on the test?
You may not. You may write it down though. No phones. Illegal maneuvering. Okay, we good with that?
Okay, let's take this quiz.
You're ready for the quiz yet? Wait, I still have some more to talk about. I know you're excited, but
Every time we just do a review, I get more and more stressed out. I feel like if I just got the quiz, I would definitely do better.
oh really?
Like even like with that, like I just
Don't.
want to do it right when class starts, or else I forget it.
I gotcha. Okay, I'll try to go faster. How about that? All right. So this portion right here, they give us the trig function of an angle. Okay, so this right here, it says evaluate the trig function is code. Okay, this means code for use your unit circle. Okay, so this is where you pull out your fancy unit circle. First thing I need to do is find 19 pi over 3 on my unit circle. Anybody see 19 pi over 3?
No.
Oh, so that means that we need to find its coterminal angle. So how do you find a coterminal angle? You subtract a full revolution, whoops, which is 2 pi. Can I go ahead and say that 2 pi is the same as 6 pi over 3? Perfect. So if I subtract 6 pi over 3, that gives me 13 pi over 3. Is 13 pi over 3 in your unit circle? Okay, let's try again. Subtract another 6 pi over 3, and that makes, ooh, I feel like we're getting close. We're subtracting a revolution. Is 7 pi over 3 on there?
No.
Okay, so try again. Subtract another 6 pi over 3, which is
1 pi.
1 pi over 3. Is pi over 3 on your unit circle?
I mean,
Oh,
I wish.
good.
Yeah.
It is, it's there.
60.
Okay, so if you're finding the cosine at pi over 3, what are you looking at?
X.
The x value. So what is the x value of the ordered pair at pi over 3? Okay, so did you remember that cosine is the x? If you didn't know that, write that down. I'm pretty sure I said that like 4 times already. Yeah.
Degrees versus rather than subtracting.
If you prefer degrees, I suppose. That would not be wrong.
What's tangent?
Y over x. You don't like fractions, huh? That much. Do I need to do question number 9? Same idea? One more? Really quick? It's 630 degrees on your unit circle. So what do you need to do if we're working in degrees? If you subtract 360, you are at 270. Ooh, 270 degrees straight down. The ordered pair at 270 degrees is 0, negative 1. So if we're talking about the sine, we're looking at the y, negative 1.
Minus 1.
Oh,
Yeah.
because you were working in degrees? Oh, okay. If you want to convert it, fair game. So that was easy?
But, so, I forgot.
What's that? Tangent is y over the x.
Okay, take up the cosine.
You could write that on your unit circle. Tangent is equal to y over the x. All right, do I need to do question number 12 where you're asked to find the sine? Find the sine. Yes, no, maybe so. What? 1. Okay, so if I am given a cosine when asked to find the sine, I'm going to use a Pythagorean identity. So do you remember the Pythagorean identity? That sine is equal to the square root of 1 minus the cosine squared?
Yep.
Okay, so that's the one I'm going to use here. So in this case, I'm going to do the square root of 1 minus negative 0.574 squared and type that into the calculator. Somebody's going to do this for me, right, people?
We're just slave labor, right?
No, I'm pretty sure this is called teaching. Slave labor would be way worse.
I mean, is it though? 0.574.
0.574. Anybody else get that number? Okay. Did you put the... Make sure that...
Thanks, baby. I forgot the 1.
Oh. So what'd you guys get?
No, it's still not right.
Don't know. Oh, because it's my
Nine.
job.
Okay, we're still not. Okay, we got multiple people agreeing. Okay. So the next thing that I have to do is decide, is this positive or is this negative? If we're working at the angle between pi and 3 pi over 2, which quadrant are we at? The negative quadrant? Yeah, the third quadrant. Okay, and the sign or the y value is always negative there, so it would be negative. Okay, do I need to do an example with the sine, or the cosine, I mean, working the other way?
It's the same
It's
thing.
exactly the same. Okay, what about tangent? Do I need to do one of these?
It's the same thing.
Should we do one? Okay. So when I'm looking for the sine or the cosine specifically, I'm going to start with the cosine. What's the equation I'm going to use? It's very long and very big, right? It starts with the tangent. Tangent of theta times the sine of theta. Nope, just kidding, I lied. Times the cosine of theta squared plus the cosine squared of theta is equal to 1. Okay, so this is the equation you're working for with when you're given a tangent. Okay, so what's my first step here? Plugging in the tangent value. So we got a 2.14 for the tangent, so I'm just going to simply start by plugging that in. And then we get to do algebra. Okay, so how do I solve this equation? Square. So what is 2.14 squared?
4.57.
4.57.
58 actually.
Oh, good. Cosine squared. Okay, then what do I do?
And then you add the cosines.
Add the cosines together. So, ooh, I can do that. 5.578 cosines squared. Okay, then what?
And then you divide.
Divide. Anybody know what 1 divided by 5?
0.1979.
0.1979?
79.
So 0.198, would you agree with that? No, sorry.
What?
Point,
No.
what?
0.179.
Oh, wow, okay, just kidding.
Wow. Square root
Okay.
those.
Square root those. And
423.
0.423. Okay, so then we have a decision to make. Is this going to be positive or negative if we're working between 0 and pi over 2?
It's positive.
Positive, because we're in the first quadrant, right? Okay, so we'll keep that positive. Now, how do I find the sign if I know the cosine? One minus, okay, 0.423 squared. Good. And that number is... Okay. And is it going to be a positive or a negative? Positive, because we're working in the first quadrant. You guys are ready for this. Let's do it.